Welcome Algebra 1, this is 6-1, Solving Systems by Graphing. The essential question is, what does it mean to solve a system of equations? Let's begin. So there's three ways to solve a system of equations we're going to learn about. Solve by graphing, the substitution method, and elimination method. Today, we're going to do the first one, solving by graphing. So what does that mean? Let's talk about what a system of equations is. And that system of equations, it's just two or more equations in a group. And in our case, it's going to be two most of the time. It might get up to 3 in Algebra 2. But just two equations together. Now, what's a solution to the system? Well, the solution is an ordered pair that makes all the systems that works for all the equation in the system. So, for example, with these two equations, y equals x plus 2 and y equals 3x minus 2, their solution is 2, 4, where 2 is our x value and 4 is our y value. And we can check this by plugging that into both equations. So I'm going to do the top one first, y equals x plus 2. If I plugged in 2 and 4, I would get 4 equals 2 plus 2, and 4 equals 4, and that checks out to be true. Let's do another one. Let's do the bottom one. Check that's true. You get y equals 3x minus 2. Well, if I plug in our values right there, I'm going to get 4 equals 3 times 2 minus 2, which is going to be 6 minus 2, and that means 4 equals 4, and that also checks out. So this is our solution because it makes, if we plugged in those values, it makes both of those equations true. It's got to be true for every equation in the set. Now, we can also solve these equations by graphing. So we're going to graph in this case. If you graph a system of equations on the same coordinate plane, their solutions is going to be where they cross. So let's graph these two lines right here. And we learned about doing that last week. So I'm going to do the first one first in blue. Y equals x plus 2. That means my y-intercept is going to be at 2. And that x is like a 1x, so my slope's 1, so up 1 over 1. So I graph my 2 points, and I'm going to draw a perfectly straight line through those points. And it's going to look something like this. And you want to be very precise when you graph. That's why I'm using these actual straight lines here. You use a straight edge because you have to be very precise to see where they actually cross. If you try to freehand it, you might get it wrong. Let's do the other one. We'll do this in red. So 3x minus 2. Minus 2 is my y-intercept, and 3 means I go up 3 over 1. And you might even want to plot more than one point. Sometimes it's easy just to keep plotting points. Up 3 over 1, up 3 over 1. So I got a bunch of points there, and that's going to be really easy for me to graph. So I'm going to draw a line going through those just like this. So, and you'll be very precise where you graph, and don't forget those arrowheads. So my solution to this equation is where they cross. And they cross at that one point you can probably see right here. What are the coordinates of that point? Look, it's 2, 4. And you know what? That's the same thing we got when we plugged it in. 2, 4, and they both checked out. So it's cool how it matches. That's what it's supposed to do. As long as you graph it straight. Alright. Is there always just going to be one solution to a system of equations? No. So there could be either one solution, infinite solutions, or no solution. And here's the three cases. There's going to be one solution when the graphs cross at one point, they intersect. That one point is going to be the one solution. There's infinite solutions when the graphs are the same line, like they're just right on top of each other, and they both graph exactly the same. Then they're going to have infinite because any point on that line is a solution, and there's infinite points on a line. There's no solution going to happen when the lines never cross, and they're going to never cross when you have parallel lines because they have the same slope and they are never going to cross. They're always just going to be that far apart. All right, that's it. Let's try some examples. Pause the video. Alright, let's graph. So I'm going to graph the first one in blue. Graph the solution, system, what's the solution, and we're going to check it. So the first one, 2x plus 4. Plus 4 is my y-intercept, and 2 is my slope. So I'm going to go up 2 over 1. I'm going to plot another point, up 2 over 1. So I got 3 points there. That's easy for me to see. I'm going to draw a perfectly straight line through those points. That's very straight and very precise. And I'll do my arrowheads. Yeah. Now the other one, let's graph this. You know what? Let's do purple for this one. I will do purple for this one, x plus 2. So 2's right here. My slope's up 1 over 1, up 1 over 1. So I see the points here. I'm going to now draw that line. Be very precise about that. So making sure I go through all those points. Okay, so I did this. And you know what happened? I bet I did not see. If you're not very careful with that blue line, that is not perfectly straight here. I can tell because it should have crossed right there. And maybe my graphs are off a little bit. So if you're not very precise with your lines, it doesn't look like they actually cross. So my blue was off a little bit. Now I fixed it. And now you can clearly see where it crosses. It crosses at that point, like right here, we're going to call it. And that the coordinates of that point are going to be -2, 0. So let's check that those are my solutions. So if I plug that into the top one, I'm going to plug the top one first. I'm going to get, and that's my x and that's my y. I'm going to get 0 equals 2 times -2 plus 4, which means 0 equals -4 plus 4, which is 0 equals 0, and that checks out. Let's try the second equation. I'll do the bottom one. Do it in purple down here. So I get 0 equals -2 plus 2. So I get 0 equals 0, and that also checks out. So they both checked out, so that is my solution. Got to graph precisely. Let's try another one. Pause the video. Okay, so that's the top one. It's not in slope-intercept form. You have two choices. You can rearrange it, or I can say, hey, I can just plot it. It's in standard form, and I can just plot the intercepts. So what I'm going to do is use the cover-up method. And if I cover up that first for this one, do the work down here, I get 2y equals 2, so y equals 1. That's my first intercept at y equals 1. So I'm going to plot that point right here. Now let's cover up the other side. So the other side, the equation is going to be -x equals 2. So that means x equals -2. That's my other intercept, and it's going to be right here. Now that I've plotted those two, I can draw a perfectly straight line between them. And it'll be something like this. Just like that. That's pretty close. You got to be very precise here. If you're not, it's going to be off. I think that's right. So that's going to be my line, just like this. Now let's graph the other one. This one, well, it's already in slope-intercept form. So we can go, my intercept's going to be right here. And my graph goes up 1 over 2. Up 1 over 2. Oh, hey, this is kind of weird. Look at this. It's actually right on top of each other. So in this case, both of these equations graph the same line. So what's the solution in this case? Infinite solutions. Infinite solutions. Because it's the same line. And, yep, that's my answer. Let's see, next one. Pause the video. Okay, graph the top one first. So y-intercept's 2, up 2 over 1. I'll plot a few more points, up 2 over 1, and draw my perfectly straight line, just like that. And then I'll draw my arrowheads. And now the next one, I'll do this in red. So y-intercept's -1, and I go up 2 over 1, up 2 over 1, up 2 over 1. Maybe you can already see what's going to go on. And I'm going to draw my line, perfectly straight line going like this. This is that other special case. These are actually parallel lines. So what is the solution to this? We can say no solutions. They will never cross. And you could have said they were parallel lines anyways. You knew that both their slopes were 2. So you knew that was going to happen, and they had different y-intercepts. That's it.